Hello and welcome to INE's CCI Service Provider version 5 learning path. Today in this video, we will talk about cloud scale networking infrastructure. So the first thing we will look at is what exactly is cloud and what's the need for going to the cloud. Now, going to the cloud has a lot of advantages. So some of the basic advantages is basically tremendous scalability and resiliency, which can basically get decreased with complexity. So as the network grows bigger and becomes a huge infrastructure, the problem would be that it becomes very static, and you cannot really scale up when you want to move from an X level to a Y level. You really cannot scale up without you moving to the cloud, and it's pretty static. So with cloud scale infrastructure, you basically can scale up as per your demands, and it provides a high level of resiliency. The next advantage is agility, which basically comes from automation and software-defined networking. Another advantage or benefit of cloud scale networking would be end-to-end visibility for extracting control and management of services. And the last advantage, or not the least, would be lower cost of ownership from automation. So higher utilization and lower capex and lower operational expenses. So these four benefits which I spoke about, which was scalability, resiliency, agility, end-to-end visibility, and lower cost. Let's in fact talk about this. Now you really cannot avoid it. Your going digital or going to the cloud is basically happening. It's already here. And if you think that your network should not go on the cloud, you should think about it again, because the effects are basically creating a sense of urgency among service providers. And it's basically an exciting time and it creates a major opportunity and also at the same time challenges for you to move to the network or to the cloud. So let's look at how moving to the cloud enhances your network and gives you scalability, agility, resiliency, your visibility, at the same time reduces your apex or capex or opex. Let's look at that. So the first thing that we would look at is going to be scalability and resiliency. If you look at high scalability and resiliency, they are basically the primary components of cloud scale networking. To achieve these attributes, the data center and the network must be able to scale and tolerate runtime failures. So if there is any issue in your network, your data center should be able to scale or automatically be resilient to failures. The amount of traffic from data centers to the internet, for example, machine to user traffic, is large and is increasing every day. Now, the amount of traffic from data centers to internet, for example, machine to user traffic or user to machine traffic, is large and is basically increasing every day. And that basically pushes the service providers to move to the cloud services. However, this pattern or moving to the cloud requires a different topology for data center networks that can scale more and be less infinite. Now, things that you should basically consider for cloud scale network. The first one is going to be an unbalanced network infrastructure that is not desirable. If one resource is less, it means the other resources are sitting idle, and that increases your cost. So the problem is that if your network is not designed correctly, then one issue with your network or one issue with your resource can even affect other resources. And that basically increases your cost. Often cloud scale networks are most constrained or least optimized with network resources. Either the network tends to be under-provisioned, which basically leads to bandwidth bottlenecks, or networks tend to be over-provisioned, which basically is wasteful and expensive. The third reason why you would consider moving to the cloud would be the fabric must be able to upgrade continuously, with new servers added, server uplinks upgraded, and leaf and spine switches added. This should all be possible without the need for fabric downtime. So when you say that my infrastructure is scalable and is resilient, you should consider all these three things: that one resource should not affect the second resource, and there should not be any bottlenecks. You should not be over provisioned or under provisioned. It should be scalable in such a way that based on your application needs, it basically scales up. At the same time, if you have to upgrade to new servers or add more links, it should be scalable enough through automation that new links or new virtual links can be added or new switches can be added so that you can scale up to your demands. Now, from perspective of agility, speed is crucial for service providers competing in the digital space. Providers can move quickly to deploy, modify, and take down services and have an advantage over others that cannot keep up with demand. Simplification and automation within the data center environment contribute to this high level of agility. For many years, applications have been built on clusters, for example, defined by virtual LAN, which is your VLANs and subnets. All networks belong to a VLAN or subnets, and all your applications were basically built on that. This architecture limited the application's ability to scale beyond the physical cluster and made the application topology dependent. Scaling the application beyond these boundaries required a complex environment of network configuration and protocols. Now, in a completely distributed architecture, the application has less or no dependency on the topology. The application can be spun up to operate anywhere. It can scale as wide as application architecture instead of being bound to network architecture. So basically, if my application requires more resources or requires more compute, it can scale up automatically. Providers can offer on-demand services based on this type of distributed architecture with great flexibility. And using automation, services can be deployed, modified, scaled up, or scaled down. It can also be taken down in seconds or minutes instead of hours or days. This is how service agility is defined in the cloud scale network. Now, what do I mean by visibility? Achieving cloud scale requires extracting control and management of services. This is impossible without visibility, because how do you know how applications and network interact with each other? You have to know how they interact with each other. Only then I have full visibility. A continuous overview of the environment allows the system to make adjustments necessary to provide high priority for jobs that require or run in real time. For example, voice traffic. When issues occur, heightened visibility contributes to reduce mean time to resolution. Visibility also provides the basis for automated fault isolation and problem remediation in the cloud scale network, contributing higher uptime. It provides application architect with rich body of data to use in analytical analysis of system behavior to find areas that can be improved. The last one was automation. A primary characteristics of a cloud scale network environment is automation. Automation reduces operational costs through service lifecycle. It does so by provisioning new systems and services on demand. Automation at scale is made possible by APIs that promote common methods to retrieve data and set object values. Simplifying what objects are read and written through a common set of data models enhances the development of the automated processes. Automation helps in provisioning of new systems and services. It also helps in configuration management or in problem resolution. It also helps in data collection for system analytics and in tasks both major and minor that currently slow down your entire operation. Customer satisfaction can increase with faster service activation and improved SLAs. This helps you to better retain customers and attract new ones. So basically, things that you should consider before moving to cloud networking infrastructure would be, is your network supporting automation so that you can add more devices or more resources on demand? So if your application requires more resources, or let's say if you require more virtual devices like virtual network functions, VNF, then you can add those things on demand. Besides that, do you have visibility, which basically means that do you know how applications and network interact with each other? So if you have the full view of that, you would be able to understand your network better. Is it agile enough, and do you have scalability and resiliency? Now, Cisco has basically added services to the Cisco IOS XR that enables networking at scale. This results in a great increase in the use of your capital expense and also reduces your operational expense because now automation is possible on Cisco IOS XR routers. Now, Cisco has the following benefits, or has estimated the following benefits for moving to the cloud scale infrastructure by upgrading your IOS XR routers to the versions that support automation. Now, it basically reduces, from a service provider perspective, it basically reduces the network cost by 50%. Now, this is an average information or average percentage which Cisco has defined, and it's mainly for the service provider environment. So it reduces your operational cost by, or network cost by 50%. It also doubles your network efficiency and performance. So your network becomes more efficient with less cost. The next advantage would be 54% of higher operational efficiency through automation, and 49% reduction in transport cost, which is through data center migration. So using cloud scale infrastructure, it really makes sense because now I can do automation, which is now possible on Cisco devices, which now takes your operational cost and your CapEx cost also less. It basically makes it less. Now, the Cisco IOS XR innovation feature, they are basically grounded on three pillars. Three things are considered from Cisco's perspective that which must be present in today's routers. So your Cisco IOS XR router has these features, and it's based on these three pillars. The first one is evolved network stack, which is your networking stack. The second is it should be a self-driven network. And the third one would be platform open innovation. So basically platform independent. So let's look at how Cisco IOS XR innovation features, which is based on these three pillars, how they interact with each other. Basically, what's your evolved networking stack? What's the platform for how it supports the platform for open innovation, or even the third one, which is basically self-driven network. Let's look at that. So let's look at the first one, which is going to be evolved networking stack. Now, new features in Cisco IOS XR software, they represent an exciting evolution of networking stack. They basically include structured, data model driven, high performance APIs, software modularity, centralized and policy driven programmability, and automation. All these things are pre-built in Cisco IOS XR routers. The Cisco IOS software also now includes integration with the industry's broad set of structured, data model-driven, high-performance APIs to provide automation at scale and basically moving beyond the CLIs. Back in the old days, we had to configure everything through CLI. But imagine configuring OSPF, or let's say if I had to shut down an interface, and assumingly I had to shut down 100 routers with 100 interfaces, I had to do that through CLI. But now the XR router comes integrated. It basically supports integration with strong APIs which can be used for configuration and also monitoring. Basically, Cisco's motto is any model, any encoding, any transport. In addition, Cisco also provides developers with Yang Development Kit, which is YDK, that lets them auto-integrate model-driven APIs from any Yang model for Python and C++. They can also get access to a model mapping software-defined kit that enables any model, including customer-specific ones, to be mapped to a native XR model. If you look at from a modular perspective, the Cisco IOS XR routers, they basically come with features delivered as independent packages. Each package can be installed and updated individually on your current major software release, basically to test and validate their respective features. No need to go through the full lengthy software release qualification. All you need is the code and you can put new features to work more quickly. Most packages don't require a system reload. That's the best part. It basically reduces downtime because now for me to activate a feature, all I need is to run the command to activate the feature and I don't need to reboot the router. With Cisco Cloud Scale Networking, the boot and day zero provisioning processes are fully automated. That's the best part about the new XR routers, the features which is inbuilt now on your new image, which basically allows you to activate any features that you need. Now, if you look at from perspective of automation, because automation is now a feature inside the XR routers, you don't need to follow a sequential step in, let's say, onboarding a device to your network. So earlier, before we had to follow a certain sequential steps where we would first plug in the device, manually upgrade the router, upgrade the image on the XR routers. Step 3 was manually stage network devices and then manually configure them. And then finally the device would be up and running. But now with automation, all those steps are gone. You can directly plug in the device, automate the boot. Step 3 would be auto provisioning and step 4 would be device would be up and running. So you don't really have to manually configure things. You can automate all these processes. So if you look at this diagram here, on the left side is my traditional network operations, how I would provision a new Cisco IOS router or an IOS XR router into my network. Basically, manually device onboarding, lengthy installation, provisioning procedures, and deployment time would probably be hours to maybe even days, depending on your configuration. But with cloud scale network operations, my onboarding becomes really fast and deployment time can be in minutes because now I can deploy a VNF, which is a virtual network function, basically a virtualized image which can be deployed, automated and automatically configured to basically support your network. Now, the second pillar of the Cisco IOS XR innovation is the self-driving network. Basically, with cloud scale networking, end-to-end visibility into network infrastructure, it basically becomes a required feature. Until now, visibility was limited to sections of network topology. Basically, all I knew about was the VLAN or the subnet. And it was not possible for administrators to get information about the network, what's happening in your network in real time. Now with demands quickly growing, you always need to see what's going on in your network at all times. Visibility must always be a continuous process. It must be automated to support the scale that you need so that you can always see what's happening in your network. Now, Cisco's model-driven telemetry is the answer for cloud-scale networking. They are available with Cisco IOS software, basically the IOS XR software. It is a new approach to network monitoring. The data is continuously streamed and captured from these devices with incremental updates. In addition to pushing vast quantities of data, model-driven telemetry uses the power of data models in two important ways. The first way is that the model-driven telemetry is fully configurable using Yang-based telemetry models. You can precisely specify what data to stream, to where and what encoding and transport using the models. No CLI is required. You don't need CLI at all. You can get all the information. You can even specify the encoding, and all this is done. Your streaming is done. Your information is captured. All this is done using the Yang-based telemetry models. The second way is also using the Yang model. However, it is using the Yang data-based model. And here you specify the data that you want in the Yang model. Now, this increased visibility, which is provided by the streaming telemetry push model, allows you to configure segment routing for real-time network optimization and Cisco application engineered routing. So here is an example of a self-driven network where if you look at this, Cisco IOS router supports streaming telemetry that gives you the ability to select the data of interest that you want to capture. Now, this data can be continuously streamed, or you can tune that to stream at a certain trigger. So real-time inspection of flexible, efficient, extensible data can be captured. Traffic analysis, fault prediction, gray failure can be based on the data that you accumulate. Also, automation and remediation policy can be created so that if something happens or something happens in your network, you can define a remediation policy which can rectify or automatically rectify your network. The third pillar of the Cisco IOS XR innovation is open innovation. Now, when you think about open innovation, it basically, you always think about the risk involved when you allow open innovation in a business. So what exactly does it mean in cloud scale networks, and how is it not a risk to your business? Well, as you know, that the digital network is coming quickly, and service providers won't be able to transform their environments or business models and offerings in time to go by it alone. It's not possible for these service providers to have their own model to allow digital transformation of their network. Emerging scalable systems take advantage of open interfaces and APIs in order to integrate systems into one complete system. That's where the openness of Cisco IOS XR routers comes in. Basically, your IOS XR routers has opened up to support third-party applications and containers with full-featured SDK, which is Software Developers Kit. This allows you to take advantage of the kind of extensibility and open innovation for networking enjoyed by server DevOps. And Cisco also provides Chef and Puppet support for integration of server DevOps with networking stack. Now, even though Cisco has opened up for third-party application, the risk which is involved in the business to open up for various platforms is taken care of by Cisco, because Cisco has maintained a clear separation between the Linux kernel and the Cisco IOS XR software stack. So unlike the competitive OS products, Cisco has not fully opened the Linux kernel to avoid security vulnerabilities. So basically, the Cisco IOS XR software is not compromised while supporting third-party Linux applications. So because of the clear separation between the Linux kernel and the Cisco IOS XR software, you are basically protected from the risk involved in your business when you open up platforms on your OS. So if you look at this diagram for open innovation, there are two choices: the native choice or the container choice. So if you're looking to use greater visibility into XR processes and file systems, then putting your app inside the XR process is the way to go. This is what we call as native app. In contrast, if your choice of distribution and isolation from XR processes is the primary requirement, then using Docker to isolate your application is what you're looking for. This is what is called as container-based app hosting. So two choices available for open innovation on Cisco IOS XR routers. So let's look at some cloud scale networking real-world scenarios. The first one is, let's say if you want a hyperscale data center. Now, designing a hyperscale data center network is all about making the entire data center behave as a high-performing network fabric. Rapid network development and performance scalability are strong requirements that do not require any dismantling of any previous infrastructure. So for example, let's say if you have a requirement for more compute or more processing, then you don't need to dismantle your previous infrastructure. You can still use that. That's the advantage of having a hyperscale data center. Gradual scalability and resiliency can be achieved by breaking up the data center into small, identical clusters and setting high-performance connectivity between these clusters. This modular design enables hyperscale service providers to quickly scale capacity in any dimension. When more compute or capacity is required, clusters are added. When more intra-cluster network capacity is required, additional spine switches are added. When external connectivity to the fabric is required, uplinks are added to the existing edge switches. Now, there are many features of hyperscale data center. The first one is ECMP routing. For most traffic, the network fabric makes heavy use of ECMP routing to use all available bandwidth and to provide performance even if one or more devices fail. The second feature of hyperscale data center is zero-touch provisioning. Now, provisioning and changes to the network fabric should be easy and fast. That's what you would think about from perspective of a design. Automated day zero capability can automatically deploy configurations on the devices depending on the role they play in the fabric. This way, a large-scale deployment can be achieved very fast, leading to an agile infrastructure. The third feature of a hyperscale data center is automation. A standard topology facilitates easier programmability, and SDN approaches can help more automation and more modularity in the network, basically making our goal to be agile as a reality. The next but not the least feature of hyperscale data center is basically streaming telemetry. Now, because of the scale of the network fabric, it becomes mandatory for you to monitor and troubleshoot in a proper way. That's where streaming telemetry plays a major role by collecting the wealth of statistics from the network on a real-time basis. This data can be used to provide visibility to ensure that quick problem identification and remediation can be achieved, and you can manage your network in a better way. You can basically transform your networks and services by introducing the cloud scale networking. So here is a real world scenario where if you want a hyperscale data center, where you want ECMP routing or zero touch provisioning or automation to be done, or you want information to be gathered so that you can give a better performance or even monitor your network in a better way, this is the way to go. Then the next example could be, let's say if you were transforming your central office. Now, many service providers have a network architecture which is composed of a national core, maybe a network backbone, and maybe different regional networks. Besides that, they also have tens of data centers, thousands of central offices, and maybe even have some separate IPTV networks. Now, these different locations are full of special purpose, dedicated infrastructure that basically works for specific purpose or specific customers. Service providers' link utilization is commonly below 40%. The total cost is extremely high, and time to market the new services, maybe network troubleshooting, or even time to repair is basically really slow than what is desired. By using the cloud scale network infrastructure, you can optimize that. So with cloud scale, your network infrastructure becomes a fabric consisting of common compute, common networking infrastructure that is modular and allows for integration of best in-class components. It extends from your edge of your network through the core of your data center with a simplified data forwarding plane by segment routing. So segment routing and EVPN can be used to simplify your data forwarding plane. Now, cloud scale solution might basically include hardwares like Cisco's Network Convergence System, which is NCS 5500 or 5000 series, or maybe an ASR 9000, which is an aggregation services router. So instead of you having multiple data centers, what you could do is have a centralized cloud scale networking office, which basically connects your metro network domain, your core network domain, and the data center domain through a controller. And your data plane is simplified using segment routing or EVPN. So this drastically reduces the overheads of the capex of investment that a provider needs to invest in. At the same time, you are utilizing all of your bandwidth, because normally the link utilization on the service provider is commonly below 40%. So now I can utilize all my infrastructure in a common place, common cloud space, where I could utilize all of my links and still have my data plane simplified using the technologies which is now available. And XR routers do support EVPN and segment routing. The third real-world networking example for cloud scale networking would be CDN, which is Content Delivery Networks. The effects are already being felt by most global content providers. The high cost and operational problems between IP video services are affecting revenues and leading to a high customer churn. Now, if you are one of the providers, you can adopt the Cisco's cloud scale networking architecture, which is basically model-driven telemetry and uses segment routing to transform your content delivery network into a high-efficient environment that optimizes your user's experience. So using the cloud scale network infrastructure, the fabric can be deployed at just the right size across many regional or global sites. Now, CDN can also be used, for example, by a system that needs to collect information about the internet and clients that can be queried by the content delivery application for best way to deliver specific content to specific users. Now, after you know about the constraints, the system can automatically instruct the content delivery server to send the content to an individual user using a specific segment routing path. So as you can see, that cloud scale network infrastructure makes really sense for service provider environments because it saves a lot of money and makes them highly scalable. I hope this video was informative to you, and thank you for watching.